Food science reveals the mysterious forces behind the humble safety pin, a staple in kitchens worldwide. Imagine a device so ordinary, yet so critical to our daily lives, that it's easy to overlook its intricate chemistry. The safety pin, a ubiquitous object found in every kitchen, holds a secret that's both fascinating and essential to its function. It's the result of a precise balance of materials and manufacturing processes, a perfect storm of science and engineering. But what makes a safety pin tick? And why is it so important to the way we cook and prepare food? To understand this, let's take a closer look at the chemistry behind the safety pin. At its core, a safety pin is a simple device consisting of a metal wire, a spring, and a head. The metal wire is typically made of steel, which provides the necessary strength and durability for the pin. The spring, on the other hand, is responsible for the pin's ability to open and close with ease. But what happens when we bend or twist a safety pin? What chemical reactions occur that make it work? When we bend a safety pin, we're applying stress to the metal wire, causing it to deform and change shape. This deformation triggers a series of chemical reactions within the metal, involved the known as strain movement of atoms within the induced metal phase, lattice transformations.
These reactions involve the movement of atoms within the metal lattice, which ultimately affects its mechanical properties.
As the metal wire deforms, the atoms begin to rearrange themselves, creating new bonds and altering the metal's crystal structure. This process is known as work hardening, where the metal becomes stronger and more resistant to deformation. However, if we continue to bend or twist the safety pin beyond a certain point, the metal will eventually fail. This failure is due to the accumulation of defects within the metal lattice, which weaken its structure. The safety pin's head is also made of metal, typically a nickel-chromium alloy, which provides additional strength and corrosion resistance. When we use a safety pin to pierce food, we're creating a tiny hole in the metal, which can lead to the release of metal ions. These ions can react with the food, potentially altering its flavor and texture. However, the safety pin's design and materials are carefully chosen to minimize this risk. The pin's head is made of a non-reactive metal, which reduces the likelihood of chemical interactions with the food. Additionally, the pin's coating is designed to prevent corrosion and ensure a smooth, even release of metal ions. But what happens when we use a safety pin to pierce a hot object, like a roast or a pizza? The heat causes the metal to expand and contract, which can lead to the release of metal ions and potentially alter the flavor of the food. However, the safety pin's design and materials are carefully chosen to withstand these temperature fluctuations. The pin's head is made of a high-temperature resistant metal, which ensures that the metal ions are released slowly and evenly. Furthermore, the pin's coating is designed to prevent corrosion and ensure a smooth, even release of metal ions. As we can see, the safety pin is more than just a simple device. It's a complex system of chemistry and engineering that plays a critical role in our daily lives. Its design and materials are carefully chosen to ensure that it works safely and effectively, even in extreme conditions. So next time you use a safety pin, remember the intricate chemistry behind it and the importance of its role in the kitchen. By understanding the science behind the safety pin, we can appreciate the ingenuity and expertise that goes into creating these everyday objects. And who knows? Maybe one day we'll create a safety pin that's even more efficient and effective, using cutting-edge materials and technologies. The possibilities are endless, and the world of chemistry and engineering is full of exciting discoveries and innovations. Thanks for joining me on this journey into the world of safety pins and chemistry. I hope you found it fascinating and informative. If you did, be sure to subscribe for more videos on science and engineering, and hit the like button if you want to see more content like this. Your support means the world to me, and I'm always excited to share my passion for science with you. If you found this video fascinating, subscribe for more incredible stories like this, and let me know in the comments what fascinates you most about the science of safety pins.